ongoing lecture series on extraction of natural products, in the last couple of lectures we started with extraction methods for volatile oils, and in that we discuss about the various types of extraction methods that can be categorized into traditional and modern methods for extraction of volatile oils. And under traditional methods we discussed about expression method, which was broadly categorized into manual as well as mechanical method, and under manual we discussed about sponge method, Scodella method and Aculase method, whereas in mechanical method, which are largely used in industry, we discuss about spumatrice method, special spumatrice method, pilatrice method. What is the difference between spumatrice and pilatrice? We discussed about Brown extractor method or extraction method, then FMC inline method, which is the most widely used method in US industries. Then we started with another traditional technique, that is distillation, and in that we discussed what are the steps that are involved in preparation of the raw material before we start distillation. What are the factors which can help in enhancing or which can affect the outcome of our distillation, and how we can enhance the outcome of distillation process in case of volatile oils. I also enlisted various types of distillation processes, that is water or hydro distillation, water and steam distillation, destructive distillation and vacuum distillation under the heading of distillation method for volatile oil extraction. So friends, in continuation with the previous lecture, today I am going to start with detailed explanation of various distillation techniques. So to begin with, water or hydro distillation. So as the name indicate, water distillation or hydro distillation, it indicates that water is used as a solvent for extracting volatile oils, and perhaps this water or hydro distillation is considered to be the oldest techniques that was used for extracting volatile oil. Though there is an ambiguity in the literature, and in in a piece of literature you will find that they have mentioned that expression method was the oldest technique for extracting volatile oils, wherein sponge method was used much before was used for extracting volatile oil much before the distillation was discovered. So coming back to hydro or water distillation, now again there is an ambiguity regarding the discovery of this technique. One literature says that the Indus Valley civilization or Harappan culture were the discoverers of this water distillation technique, whereas another literature says that Arabs were the people who discovered water or hydro distillation, which they largely used to extract out the essence from the plants and used to prepare ethers or the perfumes that were used at that time. Another piece of literature says that Chinese culture was responsible for discovering the hydrodistillation process for extracting volatile oil. But Egyptian culture was responsible for discovering the therapeutic aspects of essential oils. So a lot of debate is still going on who were the original discoverers of this hydrodistillation process that was used to extract volatile oils. Now as we know that it's a distillation process, and under distillation we boil the liquids having different boiling points, and therefore this method is considered suitable for those volatile oils that contain thermostable constituents, one, and second, those volatile oils which contain constituents that are resistant towards the hydrolytic degradation, and third, it is also suitable for the oils which have constituent with high boiling point. So we have three major criteria for selecting water distillation. One, the constituent should be thermostable. Second, the constituent should not be soluble in water, and they should be resistant toward hydrolysis. Third, they should have high boiling point. So if you have a plant material which contain volatile oils with these types of constituents, we can go for water or hydro distillation. And it's a very simple process wherein we have a large still which contains the feed material along with the water. This still is connected to a condenser, and the still is heated with the help of either fire or electrical heaters in a furnace. Then the vapors that emerge from the still, which contains both vapors of volatile oil as well as water, they pass through the condenser, they get condensed, and the condensate is collected in a collecting vessel. Now, as we discussed that volatile oils, majority of the volatile oils are lighter than water, except few exceptions like clove oil is there, cinnamon oil is there, which are heavier than water. Most of the oils will form the upper layer in the condensate, and we can remove the lower layer, that is of water, and then we can separate our oil. So this is the basic process of water or hydro distillation. Now here you can see the most widely used apparatus at laboratory scale, which is known as Clevenger apparatus. Here you can clearly see on the picture on the left side, which shows that an RBF is there, round bottom flask, containing the feed material or the plant material and water, and this round bottom flask is placed in a heating mantle, and when it is heated, the vapors of water and oil, they pass through the tube, through a horizontal tube, and then they enter into a condenser where they get condensed, and the condensate is collected in a collecting tube on the right hand side. In the picture on the right, you will see the dimensions of the Clevenger apparatus. Now this Clevenger apparatus, you can see it is the two parallel tubes are connected on two sides, one at the top with the help of a oblique tube which enters into the condenser, and the second oblique tube, it connects the opening valve and the vapor duct of the Clevenger apparatus. Now this second oblique tube is filled with water, and it helps in recirculating the water into the system. So as you can see on the picture on the left, it is a closed system. You cannot add water to the round bottom flask in between the distillation process, and therefore this oblique tube helps in recirculating the water back to the round bottom flask. So what is the amount of the water that is recirculated back to RBF? Whatever amount that gets condensed and falls into the condensate tube, similar amount of water flows back into the RBF with the help of this oblique tube. Now this process of recirculating the water, we call it as cohobation, and I will discuss this process later in this lecture. Now what are the advantages of hydro distillation? So as we have seen that it's a very simple technique, and therefore it is considered as an inexpensive technique, both in terms of its apparatus as well as the cost of the solvent that is used, and we know solvent is nothing but water. Therefore this technique is largely considered as an inexpensive technique in comparison to the other techniques used for extracting volatile oil. Then during the distillation process, it has been observed that the plant material continuously is in continuous motion during the distillation, and this continuous motion prevents the formation of lumps in the distillation still, and once the lumps are not formed, the entire raw material comes in contact with the boiling water, which helps in better efficiency of this process. And since it's a very simple and inexpensive technique, this hydro distillation technique can be exploited even at the industrial scale. No toxic solvents are used in this technique, and we know that the solvent that is being used in this technique is water, and water is considered to be the safest and the cheapest solvent that can be used for the extraction purpose. One. Second, no steps are involved in order to, no special steps are involved in order to remove the solvent residues from the distillate. So these are few advantages of hydro or water distillation. Obviously this system also has certain disadvantages, and the major disadvantage is complete extraction of volatile oil is not possible with the help of hydro distillation, because we are simply boiling the mixture of plant material and water under atmospheric pressure, and this does not allow water to enter into the deep embedded oil cells, and this prevents the liberation of oil from such cells, and therefore it is said that complete extraction is not possible with this method. Second, since we are heating the plant material, we are heating the mixture of water and plant material, this method is not suitable for thermolabile constituents, and for obvious reason, as these constituents can get degraded during the process. And the most common examples of degradation is the conversion of esters into alcohols and acids, which eventually changes the natural odor as well as the color of the oil. Then the plant material which is near to the bottom, it sometimes come in direct contact with the heat source of the furnace, and it has been observed that if the heat or the fire of the furnace is not controlled, which is obviously very difficult in this process, then sometimes the plant material get charred during the distillation, and this charring of the plant material further leads to non-agreeable odor of the oil as well as color of the oil. So these are few disadvantages, and last but not the least is the high boiling and somewhat water soluble oil constituents. They are not we cannot extract out such type of constituents in the volatile oil because we are using water as a solvent. So these constituents like phenols, they can get solubilized into the water and we will not be able to separate those constituents, and therefore such process for those oils which are rich in these type water soluble constituent or high boiling point constituents, then the process become uneconomical for such kind of oils. And not only uneconomical, if you are using this method for a plant material which contain both type of constituents, that is low boiling point and high boiling point water soluble constituent, then prolonged distillation time in order to extract out those high boiling point constituent may also degrade the other low boiling point constituents. So these are few disadvantages of water or hydro distillation. Now we move on to the second type of distillation method, that is water and steam distillation. So as the name indicates, we use both water and steam to distill the volatile oil from the plant material, and you can clearly see in this image there is a distillation still which is heated from beneath, and we place the plant material on a wire mesh. So this is the basic difference, that in water and steam distillation, plant material does not come in direct contact with the water, and below a specific level of the wire mesh is placed the water. So when the furnace is heated, water gets boiled and the steam, it passes through the mesh and comes in contact with the plant material. And we know that steam has a higher latent heat than water, than the boiling water. Therefore, this steams will cause rupturing of the oil cells that are present in the plant matrix and will allow that oil to evaporate. And both vapors of oil and steam, they leave the furnace with the help of that red tubing and enter into the condenser, where they get condensed and are collected into a collection vessel, from where we can separate oil from the water. So this is the basic principle of water and steam distillation. Now here you can see a conventional field distillation unit which is based on water and steam distillation principle. Here you can see a very crude setup of a distillation unit. The major disadvantage of such distillation unit is there is a substantial loss of the volatile oil yield from the raw material. One. Second, since you cannot control the heat in such units, the quality of the oil is not reproducible, and many a times it has been observed the color of the oil is not the natural color, along with the odor of the natural odor of the oil. Therefore, Central Institute of Medicinal and Aromatic Plants in Lucknow, they develop certain different types of field distillation units. So here you can see in picture A, it is a fixed type of field distillation unit, which any farmer, if he is having sufficient amount, he can get this kind of distillation unit set up in his field. Second one is the portable type of field distillation unit, and which can be moved from one field to another field, since it's a portable method. Now there are few advantages of these types of field distillation units that have been developed by CMAP. Now it has been observed that while using these kinds of distillation unit, there is a better yield of the oil, and not only the yield has been improved, but the overall quality of the oil was also improved. Further, these units, they have been found to be energy efficient in terms of fuel consumption, as well as in terms of low extraction time that is used to extract out the oil. Another advantage is that whatever spent waste that is obtained after distilling the raw material, that spent waste can be, or the agro waste can be utilized as a fuel to fire up these furnaces or the distillation stills. Now you can clearly see in the picture, these distillation units are equipped with a chimney. Therefore, whatever smoke that is developed during the heating of these furnaces using either the fuel or the spent waste of the distillation units, these smoke are released with the help of chimney. So in the work area, no smoke is there, no pollution is there. And the stills are constructed with the help of stainless steel material, and therefore these are considered to be highly safe, both for the workers as well as for the raw material or the oil that is being distilled off from these units, because stainless steel that is being used is highly inert in with respect to the constituents that are present in the oil. Now here you can see another advancement of the field distillation unit, and CMAP has also developed a mobile field distillation unit, and this distillation unit is suitable for small farmers which are having a small area of land and they cannot afford their own field distillation unit. So they can just hire this distillation unit on rent, and major advantage is it can be attached to any type of tractor and it can be taken to any field. The raw material can be distilled using this material, and once the distillation is complete, farmer can again return this distillation unit. Another major advantage of this distillation unit is you can clearly see there is a water tank placed in this mobile field distillation unit. So you can also use this unit where there is a scarcity of water. So in desert areas or in the areas where water resources are limited, one can easily use this distillation unit to distill out the volatile oil from the raw material. Now we move on to advantages of water and steam distillation technique. Now this technique helps in getting a better quality of oil with higher yield, and the quality of oil that is obtained by using this technique is more reproducible. The components of the oil are less susceptible towards the hydrolysis and polymerization. Since the plant material does not come in direct contact with water during distillation, therefore the constituents are less vulnerable towards the hydrolysis or the polymerization during the distillation process. Now as we discussed that steam has a higher latent heat than the boiling water, therefore the overall distillation process in water and steam distillation technique is much faster in comparison to simple water or the hydro distillation technique, and therefore this is also considered to be more energy efficient technique. There are few disadvantages of this technique, and the first one is, since the steam is being generated at atmospheric pressure, the overall pressure of the steam that is generated is quite low, and therefore sometimes if your raw material is having higher boiling point constituents, then the extraction time gets increased. Obviously, the extraction time will be still less in will be lower in comparison to simple water or hydro distillation, but there can be longer distillation hours for such type of volatile oils. Further, whenever the steam comes in contact with the plant material, it causes wetting of the plant material, because steam initially gets condensed, which will wet your raw material or the feed material. Now, this also slows down the distillation process, as the steam which is coming again in contact with the raw material will first have to evaporate the water that is present on the raw material. This sometimes also extend the distillation hours during extraction process. Now we move on to another type of distillation, that is distillation with cohobation. So I'll take back you to the Clevenger apparatus, wherein we discussed that water is recirculated back into the round bottom flask because it was a closed system. And same happens in cohobation, and cohobation is nothing but the recirculation of distilled water back to the distillation still or the distillation vessel. So this helps in controlling the volume of the water that is used during the distillation process. Since we have to recirculate the water back to the distillation still, this technique is largely used for either water distillation or for water and steam distillation processes. Again, this process is suitable for those constituents which have high water solubility, because here we are recirculating the water back into the distillation still. So those oils which have high water soluble constituents, like rose oil is there, lavender oil is there, geranium oil is there, so we cannot afford to lose those high water soluble constituents. Therefore, such water is recirculated back into the distillation still, thereby preventing the loss of such constituents. And such technique provides better quality oil by minimizing the loss of oxygenated compounds like phenols, which are also considered as water soluble constituents. Now, here in this image you can clearly see the setup of a cohobation system. This is simple, again a water distillation system, where you can see the distillation still is there, contains the plant material, it is being boiled, and the vapors of water and oil, they move through the vapor duct, enter into the condenser, and the condensate is collected into a collection vessel. And from the bottom, since water is heavier, the lower layer of the water is circulated back with the help of pump into the distillation still. So we prevent the loss of phenolic or the water soluble constituent. We also reduce the amount of the water that is being used during the distillation by using this cohobation system. Now, this is a field distillation cohobation unit. Here you can clearly see that there is a distillation still having a vertical vapor duct and a horizontal condenser attached to it, and the collection vessel is placed at a higher level than the distillation still, and from the collection vessel at the bottom there is a tubing coming back down to a tank which is meant for recirculating the water back to the distillation still. Now, the third type of distillation is the steam distillation, and you can clearly see in the image the setup of a steam distillation unit. Here we can see the steam is generated separately in a steam generator, and this steam is passed with the help of a tubing and is introduced into the distillation still from the bottom, and the plant material or the raw material is placed on a wire mesh, and the steam passes through the holes of that mesh and comes in contact with the plant material, evaporates the oil, and the vapors of both oil and water, they pass through the vapor duct, enter into the condenser, and they are collected in a oil separator. Now, the major difference of steam distillation in comparison to water or water and steam distillation is, here we are producing steam in a separate steam generator, and therefore we can control the amount of the steam as well as the pressure of the steam that is introduced into the distillation still, and therefore this system has certain advantages over the other systems. This is a commercial scale steam distiller. You can see the distillation still along with the collection vessel and a steam generator which is placed outside this assembly unit or the place where the steam generator is or the distillation still is being placed. This is another picture of the commercial level steam distillation unit. You can see that the opening of the distillation still, you can see that there is a small opening for passing of the vapors of both steam and the oil, and in the second image you can see the removal of the exhausted raw material from the distillation still. Now, as I told you, there are certain obvious advantages of steam distillation technique. It is largely preferred for high boiling point oils. It is also used for the plant material which is hard, like roots are there, woods are there, because steam, the amount of the steam as well as the pressure of the steam can be controlled in this technique. Therefore, we can easily use this technique for those oils which have constituents with high boiling point. We can also use this technique for hard plant material. Now, a single steam generator can also be used for more than one distillation unit, which makes this process more economical as well as helps in enhancing the efficiency of this process, because for every distillation unit you don't have to set up a separate steam generator. The amount, as I told you, the amount of the steam can be controlled, because if you want to make your process economical, energy efficient, you have to control the amount of the steam that is being required in the steam, distillation still. So one can easily control the amount of the steam that enters into the distillation still, so that no excess steam is being introduced into the still. Since steam that is generated is in a separate generator and then steam vapors are introduced into the still, the plant material that comes in the contact with the steam is at a temperature which is below 100 degrees. So less thermal degradation occurs in the constituent of the oil. And this technique, if we go back to the definition given by International Organization for Standardization, that is ISO, they approve this technique to qualify the substances for the definition of essential oil, and therefore this technique is widely accepted process for large scale production of the oil at industrial scale. And it's not only the amount of the steam, but the pressure of the steam can also be controlled. If you want to fasten up the process of extraction or the distillation extraction, then you can increase the pressure of the steam. But the high pressure of steam is not recommended because it can lead to the damage of the raw material. Then there are few disadvantages. You require higher capital expenditure to set up the entire distillation unit in an industry, and this process becomes uneconomical when it is used for certain low cost oils like lemongrass oil, eucalyptus oil and rosemary oil. And since we are using steam, we cannot use this method for flowers because they will get degraded with the steam. So friends, this was about 3 different types of distillation techniques, and in the continuing lecture we will discuss about other distillation techniques as well as other techniques used to extract volatile oils. Thank you.